Oh, the smart contract are secure. They are transparent, and another thing is that they are immutable, and then they have no borders. So, and another thing is that once the creator has deployed the contract, they cannot change. So nobody has control over the smart contracts. And yeah, so those were some of the benefits and the advantages of using smart contract. And also another thing is that there is a difference between, we also looked the difference between traditional contract and traditional contracts and modern day, that is the smart contracts. And one of the thing is that smart contracts are relatively cheaper compared to traditional contracts. And then the use of intermediaries in traditional contracts. And for the smart contract, you don't need to like use a third party. You don't need a third party uh, to be that is involved in your agreement. So all the rules are defined by the creator. So creator can be anybody. You can be a creator of what we are doing right now. We are learning how to do smart contract creation, and most of the smart contracts have two things that we talked about, and that was the state. The state is the data that is stored in the contract, and then we have the functions. So the functions are the code that execute uh, that data that has been provided by the users of the smart contracts. We also looked at different use cases where smart contract can be used. Smart contract can be used in banks, hospital, voting process, and also in supply chain. Most of these companies that are now moving into blockchain are actually creating smart contract. So smart contract plays a big deal in blockchain because they are now the features that are actually providing a lot of they are the ones that are actually driving the blockchain. And also we looked at ETH as the form of the gas that is used to like deploy the contract. You normally pay for gas fee using your ETH. And yeah, so we also looked at limits. So there are basically two ways that you can create your smart contract. And right now we are using limits IDE, and you can create it locally using Ganache and Trafo and the LinkedIn tool that I told you to download for syntax highlighting. And we also did a simple smart contract that is a bank and a regulator app. So previously we had done another contract that was defining the structure of a smart contract with simple getters and setters, and also declaration of variables. We have seen like two types of variables or data types. We have seen like two data types. We talked about uint and a string. So we have actually looked at two data types. That is the string and the u integer. So u integer is an assigned integer, and normally it's a positive number. And then we have int, which can either be negative or positive number, int. And with integers, like what we did, you can actually have a size of the number, the size of the integer, ranging from uint 8 bits all the way to 256 bits to 256 bits. So that's the size of that number, that particular number. So it can go all the way to like 256, and it can start from 8 uint 8. And then we talked about a string. So string is a long text. Can be, it can be words, it can be words, can be a sentence, and that is a sample of a data type. And then we actually looked at public view. We also talked about internal view, internal, and we also talked about external, and we also talked about contract inheritance. So today we will be actually looking at how the Solidity language looks like, or how it's structured. So we Solidity have what we call global variable or predefined variables. And let me just share the other slide. Yeah, so we have actually looked at selecting, we have also looked at selecting a version of Solidity. We are currently using the limits development environment, that is the online browser, and we have actually written a simple smart contract. And so today I was looking at, we have also compiled a contract. We have compiled a contract, and we have also seen the Ethereum contract ABI once we have like compiled a contract. So today, what I want us to look at is more of now programming with Solidity and learning the data types, the different data types. So I've talked about integers. So we have int and uint, that is signed integers and unsigned integers. So declared in increments of 8 bits from int.
Sorry, are you sharing another screen apart from the presentation?
Let me, this one, yeah. Can you see my screen? Okay.
What you are saying is what is a smart contract?
Okay, let me share this other one, the PDF. Yeah, yeah. So, we have talked about how we can compile. So we can compile our code using the Solidity browser. That is the limits, and we can use a get console. So this one is what we will do in later practice. In later practice, probably when we get into like token creation, we will be able to use more of this, because this one is better, because you don't have, once you start, the only thing you do is like, it's a more of an advanced level than using browser. And also you will get to see how Solidity actually interacts with other languages. So this is how the browser IDE looks like. So for now, by now we are familiar by the way the Solidity limits browser looks like. Yeah, this one is an older version. This one is an older version that was, I think, in 2017 or 2018 out there. And then we have now the basic features of Solidity. So Solidity is similar to JavaScript, or JavaScript, and Python, and also C, because it's a combination of all those languages that they were able to like come up with it. So these are some of the data types and arithmetic expressions used in Solidity, so which are very common in Java, JavaScript, and Python. So we have comments, we have primitive types, we have strings, we have arrays, we have statements, and we have Boolean and conditional loops, conditional breaks, and we have arithmetic expressions, that is equals, plus or minus, multiplication, that is modular. We have loops, that is the if else for each. We have variables. We have declared variables. Uh, we have literals, and we have methods. So methods are basically functions, and yeah, and uh, uh, some of these notes are actually not in are not in the slides. I'll provide the other types of data types that I'll be reading from my book, and yeah. So we have Boolean. Let's just let me see if okay. Let me see. Let me just go through explaining these ones, which are some of these. Uh, so for Boolean actually returns a value or values that is true or false, and we can have logic operators. So logic operators are these ones. So this one could be. So this one is a bool. Bool. Let me just comment it so that we can actually be, and so Boolean has a value of true all false. It's a value of true or false, and we have logic operators that actually also do the same. So logic operators basically do the same as true or false. It can be an exclamation mark, which means not like, which means not like, not, which means not. Then we can have and, two ends, which means and. So you can, which means and. So these are logic operators. So you can create a condition like this one. So you can say like, normally in SQL, that's what they do. You can say select, like select user name, where it's not like where it does not start with an N, where the username does not start with an N. So that's a logic operator that you are using to return a value which is either true or false. So all the usernames that are not starting with N will be outputted. And you can also add another combination on your query. Basically, logic operators are used when you are querying data. You can use and as to combine, and then there is another one which is two vertical lines, control. So they look like they are slanting, but they are two vertical lines. This one mainly means or. So you can create a logic operator the same one for like select username, where the first letter is not N, or the last letter is E. So the query now will output all the names of will now output the names of all names that do not start with N, and they do not end with E. It will output all the names that don't start with an N and does not end with a E. So that's a logic operator all. And we have the last one as equals. So this one equals. Some languages like JavaScript uses triple equals, but for Solidity and Python and other languages, they normally use equals, single, two equals. So this means all equals to something. So yeah. And lastly, we have another one. That is a combination of the exclamation that means not equals to. That means not equal to. So like what we have done in our query, no, not in our bank contract, we have a logic where we are looking whether the value is greater or equals to that amount. So this is a logic operator which is normally used when you are trying to determine whether the value is greater, or when you have two variables or two comparisons that you are trying to check whether the condition is met. Yeah. So that is the Boolean, where it defines true or false, and it's accompanied by logic operators. And then we have what now we call the unsigned integers or integer, which is we have int and UI int. So Damalest had asked about uint and integers, or what u means, and it basically means unassigned integers. So we have unassigned integer and signed integers, and they have increments of 8 bits 8 bits to 256. So we can define our value like, let's say int all u int 8. This will basically have 8 characters or 8 numbers. It will output 8 numbers. Or we can have another one that has u int 256. So by default, if you remove this, it will be 256. It will be 256. And then we have another one that is fixed point and unfixed point. So fixed point is our numbers declared with u, where let's see, fixed, and we have unfixed. So they are normally declared with like this, declared like so the first one has a u. You can either have a u like that, and m at n, where m is the size of the bit. M is the size of the bit, and it also increments the same way from 8 bits to 256, and n is the number of decimals. The number of decimals. So we can have something like this. We have you fixed with a number of bit like 32 multiplied by all x, two decimal places. So we also have an address. An address, we have actually defined what an address is. So an address is a data type that is readily available on Solidity, and it's a 20 byte. It's 20 bytes Ethereum address. Ethereum address. It's the normal address. And it's a local variable that has already been defined by the Solidity language. It's reserved for Solidity language. So basically, it returns the account balance and transfer it to the account. So that is the main thing that it helps. It's has many helpful member functions. The main ones are being the balance of, it returns the balance of a certain address. It returns the account balance and transfer money. Then we have enums. Enums. Enums are a user-defined type of enumerating discrete values. Yeah, so this one are enumerated or defined by the user. So we can have like enum. It can be enums or enum. You can have enum like name as an example, name. And then from that name, we can have an array of those enums. So the first enum, let's say like we are creating an order or on another creation contract. So we can have pending, like pending, comma, active. You can have something like that, active, declined. You can have something like that. So you can define your enums like that. Basically, these are used when you have to like change the state of an order. If you are creating an e-commerce smart contract, you need to like, if the state of the order changes, you need to like create an enum for that data. And then we have, lastly, we have something called struct. We have structs. So structs structs. Yeah, structs are user-defined containers. The structs are structs are user-defined container. So user-defined containers. So they are user-defined containers for grouping, for grouping variables, So like what we saw yesterday, you can create a struct name. Struct, it's usually have a name like struct students. Can have it students or struct student because it's one student. And then you have your array, the list of not array but places, and then the list of variables that you want, or the attributes that comes together with the student. So one thing is a student has a name, comma, they normally have a class, they normally have class, they belong to a class, then they normally have an admission, an admin number, and then they normally have uh, email, normally have email. So those are basically the attributes of a student, and structure holds those containers instead of like declaring them one as different variables and then combining them later. Solidity offers a struct so that you can be able to like group containers. Then we can maybe have another struct to define teachers or teacher. And then the same thing, we have the name of the teacher, the email number of the teacher, maybe the phone number of the teacher. Yeah. So then we have what we call arrays. Array is not an array of sun, but an array of any type, either fixed or dynamic, can have a number of things that are normally an array groups also groups things and helps people in fixing things like what we had yesterday, proposal, like this one, proposals can have a fixed this one does not have it's not a fixed array, so we can have a fixed array there and say 5. So the number of information, or the number of data that you can store in this specific array, it's a fixed one. This one is fixed. So this one is a fixed array because we have the number of inputs that we can actually input. So based from this structure, we can only like input 5 students in our system. We can actually have like 5 students in a system, or in our proposal names, or all our candidates can only be 5. But yet we need a dynamic one. If you are creating a smart contract that does not have fixed input, then you need to use the dynamic array. So dynamic array does not have any fixed, it's not fixed, it doesn't have a fixed value. So that is it doesn't have any, it actually does not have an assigned, it's not assigned any value of integers that are required to be in that particular array. Yeah, then we have time units. Before time units, we have mappings. Mappings. So these ones we will normally come in. We will be able to like see them and the uses in yeah. So mapping is a hash lookup table. So it's a lookup table. It's a lookup table that can be used actually to look up in an array, and also to look up address. It contains, so it's a hash look up table for key. So it contains things like value, value pairs. Yeah, so basically this is how it looks like. An example of mapping, we have mapping, and then bracket, key type, what are we looking for, and then we have the value of that key. You have now the value type. Yeah, so an example of such a mapping, let me show you an example of a mapping. This one. So this one is an example of a mapping. So we have the key. So what are we looking for? We are looking for address of one particular voter, which will be public and which will be now the voters from. So it's actually trying to map all the data that has been inputted in this struct. So it's looking for the key value or mapping the address of each and every voter, and it will be making it public as voters. As that now becomes like the table, like table voters also, yeah, something like that. So this will be table voters, the table of voters. Yeah, so that is mapping. And then we have time unit and eth units. So you remember the denomination that we had about wei, fini, zambo, and either can be used as suffix for converting multiples of the base unit in wei. So we have time units which basically means the units of time, that is minutes, seconds, hours, and days. Can be used as suffix to converting to multiples of the base unit in seconds. So if you are creating like a crowdfunding smart contract, then you need to like input time for different timelines for your smart contract to like the release time of your coins. So these are some of the data types that are available in Solidity. These are some of the data types that are available on Solidity. And then yeah, so let's go back to our slide. And so I've actually defined quite a number of these variables. And yeah, so another thing we did take a look was version pragma when you are writing your contract. So we talked about version pragma or Solidity compiler version, and there are so many ways that you can actually do. So it alternates source files with a prerequisite. Comes from semantic versioning, which is widely used in the JavaScript community. So mainly what this number means is that we have a patch, an issue that was being fixed, and then we have like a major update, and then once it reaches here, now it becomes like the lead version of that particular like version 1. So there have been They have been having major changes and everything. Yeah. So as you can see, Pragma comes with like an don't remember the name of this symbol, which means that, which basically means it's the same like this. It can only be greater or equals to the compiler version that you have used, and not like this less than 0. So if you use this one, it will be using the the oldest versions of Solidity. So you can write it like this, or you can write it like this with that up. Is that up and all?
Upper carat.
Yes.
I think it's upper carat. I mean, whether
Yeah.
carat
Yeah.
form
Yeah.
or whatever.
Yeah. So
Okay.
basically, make you just write it like this, or like this, or like this, but never like this, because if you write it like this, you will be using the older versions of Solidity. Then we have we have also seen how you can comment on Solidity. So you can either use the forward, is it forward? Yeah, forward slash, or you can use this one. So this one we haven't used it a lot, but if you have like a paragraph like this one, I'm having, you can actually uh, just do it like that. Uh, and it will always work. It will always work. So let me just remove it. It will work just like the other comment. So if you have a paragraph and you don't want to like write like that, this is a good way to like comment your code. This is a good way like to comment your code. It also makes neat for other developers when they are debugging your code, they are able to know what you intended. Yeah, that is clean code. A good way for writing clean code is by commenting, and also writing good ways. So this is a comment, multiple lines. These are multiple line, and this one is a single line comment. Yeah. So like what this guy has done. So you in public required, the number of the owner approval required. So this is the contract mode signature. It's a simple contract indicating the use of comments. Then we have NAT spec documentation. Is produced as an object when you call a contract object from eth.compile.solidity source. Contract have the following properties. So the contract has a code, it has information, it has source, and it has language and language version and compiler version, and ABI definition, and user doc and developers doc. So the user doc is how to use the software, and then the developer doc is how the developers can actually read and see and be able to like update your contract in case. Also, it also works for you, because sometimes you may write a project, you may start a project, and then uh, you take a nap, and the next hour you forget what was your intention on a specific line. Yeah. So it's always good to like use this procedure, like write your comments, come up with a user documentation and a developer documentation. Normally you can do the developer documentation on the code, and at the same time you can come up with a version 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 documentation. They normally look like these uh, these are developer documentation. Yeah, explaining how Solidity works, Yeah, this one I can actually share this one also, so that you can read on in depth on Solidity. Yeah, so this like documentation for Solidity, they have different version. Currently I was reading on 0.62, and yeah, so these are like a developer documentation on how you can write on Solidity. So when you are also creating a smart contract, you also need to like write your intention and how another developer or you can use it. I normally call them like I normally call say that documentation is like a letter to the future me. It's like a letter to the future me, and yeah, it's like yeah, it's a letter. It's a future letter to the future me. So this API, we have actually seen the API definition. We have actually seen the compiler version and the language version of your smart contract. It's the compiler, the same thing. Yeah, and then we have the language is Solidity, and then we have the source, that is the source of your data. So we have another thing that you can actually use. We have like art title. These are title that should describe the contract and go above the definition, the contract definition. So you can actually make it or put it like this. Art, supposed to be a comment. Art title. The title of the contract should be regulator. So you will see some of this information in let's just go to Open Zeppelin GitHub. So Open Zeppelin provides a number of libraries that has already been created. We have, those are utility. We have tokens, libraries on tokens, ERC20 token, and then we have like so you see, this is what I'm talking about right now at dev. These are some of the things that you can actually write. So this defines this is a title that should describe the contract and go above the contract. So it should be written above the contract. The author, it's the author of that particular contract, should always go above the contract definition. It should always be at this particular part. It should always be at this particular part here. So most likely above, below the license, or even below the this pragma Solidity. Then we have notice, represent user documentation. This is the text that will appear to the user to notify him of what the function he is about to execute is doing. And then we have dev, represent developer documentation. So this one represent the developer documentation. This documentation that would only be visible to the developer. And then we have at param. So these are parameters. So these are parameters. So basically we can come here and say that we withdraw all our parameters for these particular functions. For this particular function is it should be should be positive integer, should be a positive integer, amount should be. So our parameter should be an amount of, amount should be a positive integer. That is our parameter. that is our parameter. So we are actually explaining that this is a parameter that we have in this particular function with the draw, that it should be of a positive integer. So if we have a negative integer, then the developer who is developing, if we don't do that, we won't be able to like tell them what we wanted there. So some of these things are self-explanatory with developers who are experienced. They will be able to like figure out very fast what was the intention of the other developer. But for people who are joining code, it's always good to like write. It's good. Yeah, it also makes it professional. Then we have return. This one talks what you are returning. So again, we can say, again here we can say that our function should actually return a value which is return a value which is return a value which is greater than the amount. So it should actually return a value which is greater than the amount, or not return, but it should withdraw. It should withdraw amount. It should return a value which is greater than the amount for withdraw. So return a value which is greater than the amount for withdraw. Don't know if I'm making sense. Yeah, so that is the return. These are just comments and ways so that they can also be able to help you when you are interacting with different contracts. So as you can see, these guys have used that net spec documentation, net spec documentation. Yeah, and you can be able to like see, so returns a Boolean value indicating whether the operation succeeded, emits a transfer event, such documentation. So you are able to like know what is wrong with what the developer intended, and it becomes super easy. Life becomes easy. So already it's complicated for developers, so why make it more complicated? Then we have structs. So we have actually talked about structs, and we have said that they are user-defined containers for grouping variables. And the advantages for describing a set of variables that will be repeatedly used to describe something. So you just need, like, if you are declaring a variable that you see, like for the name for, let's go back to our struct that we had defined up here, the example that we had defined. So as you can see, this one, we need a name for the student, and we also need a name for the teacher. And these will be conflicting variables. So we can actually group these variables that belongs to the student, and then we group all the variables that belongs to the teacher. We can actually have like the same thing, like a teacher must have a class, and then they must have an email. You see, this one will be conflicting. We will have conflicting variables, a class. So when we are like storing that variable, we might like put the records pamoja, like no, we can like put the variables. We can, if we are creating a student, the name of a student may go to the long variable. So there is no way, if we don't have a struct in our contract, there won't be a way we can be able to like identify this is a student record, or this is a student uh, student information. The other alternative we would have is to like create another smart contract called smart student smart contract, which is a tedious work to create another contract and then start inheriting the other contract. But with a struct, you can actually come up with the same group of in variables in the same contract without having to create another smart contract. So that is the advantages of structs. Defines a new type. It's cheaper to use than abstract contracts, which require paying gas for contract creation. So this is the best, the advantage of structs. Like I've actually said. So you see, you will have like you will have two contracts and then another contract to merge the two contracts. So those will be two contracts. Those will be two contracts, and then communicating to another contract, it actually consumes a lot of gas. Then we have these are abstract example. So this one we have done. You can imagine you have a contract that registers people, and you will do that continuously. Then you will need to like define a struct and then do the mapping. So you will use the uint, this one, as the integer too. Like every birth date is unique for everybody for this particular contract. So you can actually add an ID here to be able to know which person has this ID, and then we do a mapping. We do a mapping. We will do a mapping of the person, and then this mapping we will call it people. So it will be people's table. It will be people's table. So once you have like created, so every time you add a person, they will be mapped here, and then it will be a people, like a people's table, and then we will have the uint ID, person ID. So person ID, which is separate. So then we have conditional expressions, uses control structures that are typical in other languages. So we have the if this, like the one we did yesterday. So we have a condition here. So if check value, so we created a check value function, this function. So this function is actually checking whether we have amount or value, or the value of money we have in our bank is greater than the amount or equals to the amount we want to withdraw. So this one is a condition or an expression, and it has to be meant, it has to be like fully filled so that we can be able to withdraw. If we don't have that, then so expression are good when you are like trying to see if a particular condition is meant. Then we have the else. If else, it's actually accompanied with if else. So if this condition is meant, then we can actually have another else and put a condition there, and then output something. So you must like do another condition like there, and then pass what you want to like check. So yeah, so this one could be like if check amount is great, else if it's less, output something, return something, return you don't have like enough, don't have enough don't have enough funds. So then we have the while loop. So this the while and do, and then we have for loop, and then we have break. So break, and then we have continue, and then we have return, and then we have this one, the last one. So normally expressions all use all control structures are good when you want to like know whether a certain condition has been met. And then we have loops. So loops, so operation costs gas. So it is best to construct loops to repeat a known number of times. So you can use like a for loop. So this one is a for loop. You can use a for loop or a do while loop or a case break loop, which goes for a number of times. And then we have the Boolean expressions. So Boolean expression, we have seen it. Yeah, we have seen the Boolean expression, which is widely used for throw, which is reverses all side effects. So we can have like function transfer, and it returns a Boolean. So if sender balance is equals to balance is message sender. So message sender is a predefined group of variable. It actually draws the or it gives you the address of the either the account in question. Yeah. And then here you are looking, you put a condition here. If the sender balance is greater or equals to the value that they are trying to withdraw, and remember end. Now you see how you use the logic operators, So if the sender, you're combining the if statement that we saw, that is an expression if, and now you are passing your condition here using the logic operators. So if sender balance is greater or equals to the value that they want to transfer, and value is greater than zero, So there are those customers or users who would like try to like send they would like try to send money even if they don't have something. There are those users who actually don't believe that there is a, yeah, and the value is greater than zero, then sender balance should be minus. So the sender balance, that is the balance of the sender, should be subtracted from the value they are sending. So our value here, we can equate our value with like 50 bob, and then we are checking whether the user or the sender who is trying to send the cash, whether they have 50 bob in their wallet. And if they do have if they do have a balance, if the balance is greater or equals to the value, and the value is greater than zero, then we subtract, we subtract the sender's balance. For example, it would be 100. We minus the value that is 50 bob. Then balances should equals, now the balances should now be registered on the user's account. Then new balance should be actually be displayed on the new account. Then we should also add the balances to the sender of the address. So here we have like two parameters. We have the address of the one who is being sent declared as two, and then we have the value, which is of a value of which has an increment of 256, and then it's a Boolean. Because it actually have a condition that is checking which should be true or false. If the transaction goes, it should actually return a value which is true. If the transaction fails, it should actually return a false, because if all these conditions that we have set here are not met, then the 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 values that should be returned is false. So the balance of the sender, the receiver should be updated. So the value that we have now subtracted here should be added to the address of that person. And then we emit that event transfer of the message, the sender, that is the sender, and then the address of that particular person, and then the value that we have been able to transfer. So this is an event transfer. It emits an event, it emits transfer event. So event is, we haven't actually looked at events, and I haven't talked about events. So this is something that I will talk in a later class, and we will be able to declare to emit events in our contracts. So yeah, so we have actually seen predefined global variables and functions. So message.sender is a predefined global variable. This one is predefined, it's already created. Yeah, so from that point, I think we can try and, hello, have I lost anybody?
No, we are with you. I'm with you.
If anybody is drowning, just raise your hand and ask a question.
We are not drowning yet.
Okay. So so today I had promised you, we will be doing something to actually upgrade ourselves. So this the contract that we had yesterday, and we have actually covered a lot. We have actually covered a lot on we have seen an interface, how you define an interface, and then how you define like a contract. So today we will be doing something called library creation. So instead of there are those libraries that you can create. Those are, if you create a library, that contract cannot be like, it doesn't consume gas, because you will now be using it. You only deploy it once, and the gas is not like used a lot. So interfaces. Uh, we have talked about interfaces, and we have seen how to like actually inherit contracts. So this our contract bank has inherited some of the functions from interface library. So you can create a library to do like certain functions. And it's to get us started, we will start with a simple, let me just open my tutorials and demos. So we thought I saved this one tutorial. Yeah, can't seem to find the custom error handling and modifier. So I also showed you how you can you do error handling on Solidity. There was something that I was supposed to show you yesterday, but I think because of time, I wasn't able to. That is modifiers. The one that I was talking about, that only owner, something like this. I think I mentioned something like this. Let's don't seem to find the contract, but let's just do libraries and imports. So let's do library and imports. So far we have actually defined everything, like everything in the same file. So today we will see how we can import another contract an outside contract in our code, in our system, in our contracts. So we'll have a library, and so this one is a simple library implementing, is a simple Solidity program implementing a library. And libraries, just see what libraries. So libraries are very beneficial if you just want to, like, there are some specific functions that you will use in your contract creation. So if you are using some functions like this one, let me just create this one isn't in again, we will go back to so our limits IDE, and then just like we have been doing, we create a library code. It's supposed to actually name it dot sol. So this will be a library. So I'll let as I explain the code. So we have a function that does increment. It does increment value. It's incrementing value of a certain of this particular contract. This one. So this one is a test for the library that I created, and see. So this is a library. Let's say we want to, like, increment our balance with our bank balance without actually without using this particular way, without using this way, without using this. So we need to create a library that will be doing that for us. And we will create, we will, it's just a normal contract. It's just a normal contract. The only thing is that it differs from abstract in this way. The functions are actually determining something. The functions are well defined. These one are not defined. As you can see, the functions are not defined. And then some of the functions are made pure. So pure is a word that came. It's a word that was introduced in 20 either 20 either 20 20 either 20 last year or 2019. Function pure, just a minute. So it's a function that has, the word pure has, so functions can be declared pure, in which case they promise not to lead from or modify the state. So that's the work of pure. So in addition to reverting a state change is not considered a state modification, as only changes to the state made previously in the code did not have the view. So libraries, the work of libraries is to actually define a contract and define the way the contract will look like, and how some of these things should be no, interface is the one that defines the contract, but the library makes, let me just, sometimes they confuse me. Yeah, sometimes the contracts and library should be contract and library name should also match their file names. So if a contract file includes multiple contracts and or libraries, then the file name should match the core contract. This is not recommended. Okay. They sometimes they sometimes confuse me. Okay, let's just define the library. So sometimes library like the libraries that we had on cryptography, they basically are written to like help you, so that you can be able to like reuse them, so that you are able to reuse them once they have been written. So like Open Zeppelin has a library of contracts. So this one is an interface, and then we have a library here, like this one. This one is defining a time lock. It's defining a time lock, and this one you can actually use when you want to like you can see this one is a function to for release. So this one is for release, and token time lock, current time is before release time. So this one you define, it's already defined for you. You don't have to use it. You don't have to like create that function again, and it has already been built for you, like how you can be able to like use it, and it's a way to like lock the funds or the release time of your crowdfunding. So this the use of libraries. They come well in handy because you don't have to like continuously create new libraries. So we can actually go ahead and define our contract library, and then see how we will be able to like use and how simple it will be. So as it is our norm, we will have to like define the license, and then define our compiler. So we yeah, semicolon. Yeah. So as you can see, we can actually use it like that, or use it like that, but never like this, never like that. So never like that. It will work, but your code will be working with outdated compiler version. So always like that, or like this. And then we will define our contract as int extend, contract int extend. The naming does not really matter, because we can just use like library, and not use don't use reserved words, and use ads extend, and use ads extend. Then the way we normally do it. And then we have function increment. So this one is an increment function. We will be using it to increment our values. So you can use int naming of variables or parameters. So we can have these variables that are here that we can normally write like uint age. That does not have like a problem. It doesn't have a problem. But when it comes to if you're writing a function, there is a way you should name it, and that should be like with an underscore. So parameter should be written in underscore, public pure, which returns a value of integer. So this one we can remove that one because we don't need it. It will be of value in integer, and then it should return an increment. It should return self with we added a one with a one increment, incrementing a value of one, incrementing a value of one. Then we'll have another function that is decrement, which will have the same way, but we will be decrementing or decreasing with a value of 1. So we will return the same value, return self, and underscore self with minus the value of 1. So this one, we can actually use it every time we want to use this function in our bank. We can use it there. And if we have another function, we can actually use it. So this BA extended. So then we will have this other one, increment the value by another value. So you will be like incrementing the value that we have with another value. And we have a function increment by a value by another value. So the same thing, but this time we will define two values. We will have two parameters. We'll have that value self value, and then the function should be pure. The function should still be pure. Just copy. Function should be pure. The function should be pure, and then we will and then it should return. So let's say you have a value that is like 10, and you want to increment it by the value of 5, so that value will now the self will be 10 plus 5. Then you can also decrease by a certain value. You can decrease by another value. Decrement. The logic will be the same, so it will be minus the value. So it will be self minus the value. So we can actually try and see if our contract is working as we intend. We have actually defined it. And yeah. So let's say we have a value that is like 10, and then we can call it Sorry, let's just deploy it there. So we have a value that is 10 or 100, and then we call it. It should be increment in. It should be decremented. So we have decreased it with 1. We have decreased it with 1. Then we can see if our decrement by value is working. So we will input that 100 and then decrease it by the value of 8. So we have actually done that, and it's 92. Then we can try and increment that value, the same value, 100. We will increment it with 1. It is 101. We have 101. And then we have this other one, the increment by value. So we'll do 100 and then try to increment it with like 50. So we should have 150. And there we have it. We have 150. So our library is working as we have defined it. And yeah, so that is how you like create a library. It's just a normal contract, but the functions are most of the functions in a library, all the functions are well defined. And yeah, so we can go back to the other contract and see how we can import now, how we can use this contract in another contract. So we have seen inheriting a contract in the same contract, inheriting and using it functions in the same contract, like the way we did it in a bank with the regulator contract. So let's see how we can actually import this intent. And we will use, or we will create a test library, test library contract. So we'll create another contract just the same way, not there, but here, and call it a test contract .sol. This one should be small, cause, and then the same way we did it, we will define our pragma or our Solidity compiler and our license, and then we will just call contract contract test library, contract test library, and then we will now import our library now. So import libraries here. So you import your libraries here, and the way we do it, if you have a folder, or if the contracts are in the same folder, like right now they are in the same folder, so importing will be easy. So we will do import int, should be caps int extended .sol with that, and then we should have, let me see if we Sorry. Don't forget the quotation. Don't forget the quotation.
I think the I is a small letter.
It's small.
The I is small letter.
Yeah. Mhm. Let's see if I remove it from the folder. Let's just change the name and see if, I don't know, not the name. Let me just change the position. Let me change the naming. Just create it from outside and then outside the folder. Okay. This compiler does not want us to compile. So just use it when it's outside the folder. Yeah, like that. Use it when it's outside the folder because now it's working. But I think I should have like added something like this. Then it should have worked. It's still working. No. Yeah, so that is the way to import. Sometimes imports are headache when you are working with multiple folders. You are working with multiple folders and you have created like different files and you want to use it in different places. Yeah. So now, after importing, that's how you import. So that's how you import, and then below line, the first the below the contract or the name of the contract, that's where you now use, you will use the contract, and we normally use the word using. So use the contract here. So if you use it below, you won't be able to use this name. You won't be able to use it name. So remember the naming of our contract. We named our contract using our contract was it capped? The name of our contract was ADS extended. So we will use that name as ADM using ADS extended for uint So this uint, and then don't forget your and then don't forget to put your semicolon. Primary name expected using so we'll have function test the increment. So this one, and then our function will now call the function library name expected. Let me just try and copy everything here and then paste it right here so that we can debug it when we already have. Library name expected. Should it be the name of? Should be the name of the contract. Should be the name of the contract. Didn't mean I have to move this other one. Let me move this other one to. Let me move this one outside. using library, using just let's just check. This is bad, very bad. So this error, I'm not sure why it's appeared in, cause it shouldn't be purely because we have actually imported the library quite well.
But I thought there'll be a command like import the library as.
You just call the name of the file. You just call the name of the file.
You don't need to do any other thing like 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 in Python when you are dealing with a table, you import pandas as PD, something like that.
No, you just import it like that, and then you use the name.
Okay.
So let me see if
But
I
after,
if
okay.
I if I okay, I see. Sure. Library extend, it's not found. Then once it's found, it's so there is something which is happening, but I'm not. I'm thinking it's the name using. Well, as you can see, we are actually doing the same thing here. We are using safe math the same way we have actually imported it here. I think it's just a small thing we are missing. And library name is expected. So the library name is ADS extended, and this is what we are using here. It's the same way these guys have done this here. It's the same way they have done it here.
Yeah, but they're using the name there. If you look at it, using safe ERC20 for ERC20. If you look at it, the ERC is called upon down. I think
Let's
in
see.
our own case, you need to use a library where you have a ADS library. Check it out.
Okay. Think okay. Coordinate. I should
Where you have
actually
ADS extended, it should be library.
library instead of library it should be ADS.
That is it. I think that should fix it.
See if we do that. Oh no. Well, we have a problem. The same way. It's the same way. So our code is the same now. Wow. Well, we have a. I'm not sure what is going on here because everything seems to be light. Let's see if the name is okay. Using safe math. Wait. Using ADS extended for uint. Yeah, place we have like let's just copy this other one and see if see if it works. This is very weird because now it's working. It's very weird. It's very weird. I think it's the naming. I think it's the naming of our contracts. I think it's the way we had named our contracts. So make sure you light the name the light name for your contracts. Yeah, I think it's the naming. So we can actually go ahead and test our contract. So we have this one library test, and as you can see now, they have been like, since we have used the library, now they are like now joined. We have like grouped them together. So we have test library. So this one will be the one which will be deploying, and then we can now do our testing. So we had the function test increment, and this one should have been our ADS. This one should be our ADS extended, and this ADS extended, we will have a base value that will be automatically incremented. So we can have a base value of the same value that we had, that's 100, and then we have actually decremented it. So without having to like add the you just add the value and you decrease it with 1, and then we will increment this other one. So we'll have the base value again, and we will have the value that we want to like decrease it with. We can have a value of 2, and then so we can do it multiple times. So as we continue doing it, it should be decreasing by that value. So we can add like 24, should decrease. So it goes 1. We can add a loop here so that it actually does a continuous loop of a continuous decrement. Then we have the last one, the test increment. We can increment again with 1. And then we can also do an increment with a base value of, and then we increase it with 25. So we can call it, and there we have it. So we can add another one and we increment it. So we have 354. Yeah. So this is how you do increments and decrement, and how you import libraries, and how you can be able to decrease and increase by creating different functions. So I'll try and I'll go and check the reason why. I think it's the naming of these libraries. So the library should have the same, the contract should have the same name as, the contract should have the same name, because we had previously written it like this. We had previously written it like this. So the name should be different. I'll take a look at the documentation again and see what we did wrong. What we did wrong uh, in yeah. So that's it on different variables. That's it on different variables and different data types. So we have actually seen a Boolean, and we have seen loops. So for loops, this actually was supposed to be a one in. Don't ever use a loop. So if you want, you try as much as possible to avoid loops, because with loops, if you have a continuous loop, your contract will use a lot of gas. It will use a lot of gas, and that will cost your users a lot of money, and they will be complaining. So try as much as possible not to use loops. If you use a loop, make sure you have limited the number of times the loop can actually loop, like minimum. Don't, yeah, there are those loops which are continuous. If you have ever worked with loops like for loops and while loops, there are loops which are continuous, and the more the loop, the way if a loop is a continuous loop, then the transaction will always be continuous for the user, and it will cost them gas. So operations in Ethereum cost gas. Every action or every operation that you perform on Ethereum, it costs you gas. So we have seen structs. We have actually talked about structures. We have seen Boolean, we have seen integers. We have two types of integers: integers which are assigned and unassigned integers, and then we have uh, fixed numbers, and then we have address, and then we have enums, and then we have structs, and then we have arrays, and we have mapping. It's a hash mapping. We have said that a mapping is a hash lookup table for key with value pairs. So it can have a key with its value, and we have seen an example of a ballot, like the ballot which has a mapping of the address of voters. So the value here, the key here being address, and the value being the values of the voter. So yeah. Yeah, so that's it. In case you have a question or a concern or a comment or something, uh, yeah, this is the right time, and you can ask. Yeah. Hello.
Yeah, no question from my side. No question from my side.
Sure.
Quick one.
Yes.
The slide. Can you? I mean, can you help us share the slide?
The slides, the other slides.
Yeah.
Okay. Okay. I'll do that. I'll do that.
Okay. There's no question from me.
Can you share the link? The one for Solidity,
The one for Solidity. Okay. Let
the
me
one
share.
you had said before.
Okay. So you can always go to docs.solidity and see different updates there. So it has a whole documentation of about Solidity. Okay. Any other question, request, or something?
No.
Okay. Yeah. So then we can call it a day and enjoy the rest of your evening. Bye.
All right, bye. Thank you.